Good morning, and thanks for waiting, everybody. Thank you again. Welcome to Migrating Your HIPAA-compliant healthcare analytics to AWS. Today's speakers will be Chris Crosby, a partner architect from Amazon Web Services, Fahad Aziz, co-founder and chief technology officer of CareMerge, and this speaking now is Jerry Miller, founder and CTO of Cloudticity. Just a little bit of housekeeping before we start. Everybody will be muted throughout the presentation. If you have questions, please feel free to type them into the GoToWebinar tool, and we'll answer them at the end of the presentation. We'll make sure to leave ample time for question and answer. The recording and the slide deck will be sent to all webinar participants after the event, and feel free to share those outside of the attendees of this event. Briefly, today we'll talk, Fahad from CareMerge will present some information about their migration to AWS, and particularly focus on how they've implemented analytics on AWS. I'll talk a little bit about healthcare on AWS in general, including things like BAA compliance and managing PHI on AWS. And then Chris will dive in a bit deeper on big data and analytics architecture on AWS, particularly focused on the healthcare industry. With that, I'm going to pass it off to Fahad.
Thank you, Jerry. Hello, everyone. I'm Fahad Aziz. Thank you for joining this webinar. Before I talk about what we do and the big data, I want to remind everyone of last few years of Steve Jobs. As we all know, he was being treated for his illness, and there were a lot of doctors, physicians, pain managers who were trying to treat him. But there was a huge problem that all of them were not talking to each other, to the point that his wife, Laureen, had to invite them at their house, made them all sit in one room, and asked them to create a coordinated treatment plan. This is not a one-off problem. We all face this problem when we go to hospitals, when we take our kids to the doctor's offices. The information is not being shared. And we don't have the luxury to invite our doctors at home. This is where CareMerge comes in. And we decided to solve this problem for all the population so that the information can be shared and the care can be more coordinated. When we decided to solve this problem, we wanted to know where the biggest pain is. And obviously, the biggest pain is with senior population. As you age, you have more chronic illnesses. You need more care. And we went into senior homes. And over there, we saw that you have a lot of people who are making decisions for seniors. So first you have 100 or 200 seniors living in a building. There is a staff members, 70 or 100 in 3 shifts that are taking care, and they're not talking when the shift ends. No one knows what happened in the morning shift. Then there are family members who are not in the building, but they are equally involved and helping make decisions. Then they have outside providers like doctors, therapists, hospitals, and other entities who are also making decisions and providing treatment. And finally, you have insurance companies who are paying for it. So if you look at this picture right now, you can see that the only way these guys are talking to each other is point to point through technologies that were built in 80s and 90s. That is telephone, faxes, sometimes they leave sticky notes for the next person. So not only these technologies and this type of communication is ineffective, it's also very insecure. So this is what we try to solve. We provided them a care coordination platform. Every time a care is provided, they capture it. We have an authorization engine where you can authorize family members, doctors, therapists, give them different level of authorizations. As soon as the care is provided, we share with the other authorized person, and everyone knows what's going on with the patient. So this is all great, and things were looking good. We started signing up a lot of senior living communities, and then something more exciting happened. We instantly saw a network effect. So a senior living that authorized a doctor, now the doctor wanted to authorize another patient, and the other patient wanted to authorize a hospital, and hospital wants to authorize another hospital, and so on. So this network effect was great. We didn't have to sell the product. We saw people signing up and people getting authorized and so on. However, it also created a bit of a concern. So my team comes to me and asks me, do we have the technology and the infrastructure to support this exponential growth? And my answer to them, we need to find out. I don't know. We were hosting with an infrastructure vendor out of Louisville, Kentucky. I fly there. They give me a tour of the facility. They show me the biometric security, the backups, and all that. Then they take me to the location where my servers are installed, and they all look great. They're very secure. The cables are nicely plugged in and all that. But as I leave that facility, I'm very, very worried because what I looked at right now, it seems there was a lot of manual intervention. So anytime I want to increase my capacity, I have to submit a request. The server needs to be ordered. Someone has to manually go in and install them and rearrange the cables or whatnot. While we were thinking about all that, we had an awful experience. The facility had a DOS attack. Someone attacked some other customer, but since the bandwidth was shared, our site was not accessible for a few hours. So for that reason, we knew that as we're growing, this is not going to work. This is where we got introduced to Jerry and his team, and we did an analysis together to figure out what are the biggest challenges that we are facing right now. And the biggest one was obviously scalability. We wanted to make sure that the application is scalable and is always available to our customers. As you understand in healthcare, and especially with senior living, timing is everything. So if a senior is discharged from a hospital, next 3 to 5 days are very critical. They need to keep changing the medication. They need to keep an eye on his blood pressure and his heart rate and so on. And if by any chance the system is down for a few hours, that could mean life and death. So for that reason, it was very important that the system needs to be always up and scalable. The next piece that was extremely important to us was the continuous integration. We knew that we are in a market where innovation is not as fast as it should be. So for that reason, we were releasing our packages and features every week, and we require a lot of automation to deploy, to test. If there are any alerts that needs to be created, we need to get those alerts in timely fashion and so on. And when we were doing our market research, we met with few similar organizations who had 300 or 400 engineers, but only 5 or 6 DevOps engineers. So, and the reason they were able to support that huge development effort was only because they have put in all the automation in place. And that's where we wanted to be. The third item was security. Security in healthcare, as we all know, is paramount. It's important. And security at level of storage, at level of transaction, or backups. We wanted to make sure that at no point there can be a breach. And if there is a breach, it's controlled. We know about it, and we can stop from it to spread. So for all that reason, that was also extremely important. And finally, which is also the focus of today's presentation, is big data. And we'll talk more about it in the next few slides, but we were capturing a lot of data, and we wanted to make use of that data, and we needed an infrastructure that can help us do that. So as we all know, when you start running some complicated analytics, you don't need one processor, you need multiple processors, but that requirement is temporary. As soon as you finish your analytics, you don't need those processors. And there must be a way to turn on and off that usage. So let's talk a bit more about big data. Big data in healthcare is very different than in other industries like financial, e-commerce, or even Internet of Things. Human body is complex. When we are capturing healthcare data, we're talking about conditions, medications, vitals, and outcomes, and so on. So this can grow exponentially, the size. However, it's equally exciting opportunity, because if we can put all this data in use, we can get some actionable insights that can not only help save the cost of healthcare, but more importantly, it can help us improve care and for the population. So for that reason, one third of our focus in our organization is on big data. So for today's presentation, I tried to collect some of the data points that we have in the system, just to give you an idea. So there are data points that are real time, that are occasional, that are weekly, that are quarterly, and they all come together to create something that's very meaningful. For instance, if you look at this slide right now, I have some devices that's giving me data like heart rate, blood pressure, sleep time. This is real-time data. Then I have some observations. So if someone had a fall, someone is feeling depressed. So this is the data that I'm also collecting as it happens. Then there are social data. So if people are attending activities, I want to know what type of activities they're attending. These are physical activities, they are social activities, emotional activities, and so on. Then you also have assessments, which are quarterly and annual assessments that capture a lot more patterns. For instance, mood and behavior, cognitive, communication, vision, physical functioning, and so on. And finally, you have clinical data that captures medications, whether they are taking medications, whether the medication changed, and so on. So now, with all this data, what do we do about it? This is so much, this is a gold mine. And for each resident, you have all this information. So number one thing we need is the technology to help us put this data in good use. Let me see if I can move my slide. Okay, great. So basically, we put that into 4 components. Number one was storage. So these data points that you just looked at is for one person. So imagine when hundreds and thousands of people are now using our application, each one have all these data points. We need a storage that can grow as needed, but at the same time it's affordable. We cannot have the hardware purchased and acquired and it's not being used. So it was important that it's manageable. The cost is also manageable. Now, as I mentioned before, when you're running these analytics, you need a lot more processors. But as soon as the analytics stops, you don't need them anymore. The computation should also be scalable. Something that's very interesting about business logic is that, as we all know in big data, sometimes we don't even know what we're looking for. We have an idea what we're trying to achieve, find, but we don't know what exactly we're looking for. For that reason, the business logic needs to change on the fly. So as soon as we bump into something, we just change the logic and try again, and then try again, and then try again, until we find something that is close to what we're looking for, and then change our direction. So for that reason, again, we wanted to be able to do that and had the infrastructure to support it. And finally, the BI tools, the visual tools that sits on top of it, has to be able to be installed. There are a lot of complications with the technology. Those BI tools are built on Linux. Sometimes they are built on .NET. Now you need to have an extra server or extra instance. So all that needs to be taken in consideration. With that, I just want to share 2 really good examples of how we made use of the data. Number one example was with the hospitals. They wanted to stop readmissions. 40% of the readmissions are coming from senior living communities. But once they discharge someone to a senior living community, they have no idea what's going on with them. So this is where we came in. We were asked to identify people that are of high risk of readmission. So we look at the data, and some of the examples that I have on the slide right now, we looked at the people who were recently discharged. We look at the weight loss, whether it was significant in next few days, whether the person has chronic illnesses, whether his sleep pattern has changed, how are the oxygen levels, did anyone notice or observe a fall, and what are the comparable cases in last 6 to 12 months from the same zip code, from the same population. And we put that in our algorithm with weights. We applied some intelligence, and with that we were able to uh, to find some people that we could recommend, saying that they are a high risk of readmission. Again, it was not by any means a perfect analysis, but it got us closer and closer to what we were trying to do. So that's one example. The other example was with the people who are living in senior living communities. So as you know that now their stay are longer. They're not temporary. Sometimes they're staying for a couple of years. So it's not the whole phenomena that this is senior living is for the end of life that's changing. It's basically their lifestyle. And for that, it becomes important for senior living communities to keep them happy, excited, motivated, and let them have fun there. So, but now they need to know if that's not the case. So they will need to know who are the people who were really excited, but now things are changing and they can see that they're depressed, their health is declining, and so on. So for that, we went back to our data warehouse and we started picking up things like, did anyone observe the change in mood? Did anyone observe that the person is not talking anymore? Are they attending less social events compared to what they were attending in the last 2, 3 years? How's their appetite? This is something very exciting and important was that have they talked to their family members in the last 2 weeks or so? You will be surprised to know how important this one data point is and how much it contributes to depression. Then something about medication, whether the medication has changed, does the change had any interaction, and so on. And what are the comparable cases. So again, we put all this in our algorithm. We added some intelligence, some weightage, and all that. And interestingly, the results were very close to what we wanted them to be. So this was much better than the previous example for us. But again, there's a lot of room for improvement. And the reason I just shared these two examples to give you an idea of how we are using the data that we are collecting for some actionable insight. With that, it brings me to my final slide. Again, we're just getting started. But what's most important to us and many of you is that you need to focus on your application and your big data analytics. You cannot spend time on worrying about infrastructure, whether at the night at some night system will go down, whether to order more capacity you have to place an order 2 weeks earlier, and now you're dependent on someone to go and install the devices. All that stuff will slow you down. All that stuff will stop you from innovating, from meeting your goals. And for that reason, we have been very fortunate to partner with AWS. We are one of the 100,000 companies that uses them, but we feel that we benefited a lot from their services. So thank you, AWS, and thank you all for listening. If you have any questions, I will share my email at the end of the presentation.
Great, Fahad. Thanks so much. It's really a pleasure to be able to bring a customer to talk publicly about some of the solutions that they've built. Let me talk a little bit more generally about what we're seeing across our customer base and in the industry. And then Chris will dive in and give some real deep specifics around actual implementation on AWS. Just really briefly, Cloudticity is an Amazon partner. We're the only Amazon partner that exclusively focuses on building HIPAA compliant solutions for Amazon Web Services. We built the first patient portal on AWS. We got the first meaningful use stage 2 attestation on AWS. We built the first health information exchange on AWS. And given that that's all we do, that's our entire business, we can really prove that you can and you should run your healthcare applications on AWS. It's safe, it's secure, it's very cost effective, and our entire customer base does exactly that. So let me first talk a little bit about healthcare data on AWS and some of the specific requirements that you need to focus on. And then we'll talk a little bit about some industry trends that are really driving AWS adoption, particularly in the big data and analytics arena. So AWS does sign a BAA, that's a business associate agreement. It does place some restrictions on the way that you can use AWS, particularly if you're using electronic protected health information or EPHI. So as is required by federal standards, customers are responsible to encrypt EPHI both in transit and at rest. That's not only on its way to AWS, but that's also within AWS. And so anytime any data are traveling anywhere, they must be encrypted. Anytime they're stored anywhere, they must also be encrypted. A second requirement is that customers using EC2, that's the Elastic Compute Cloud, must use dedicated instances for any instance that processes, stores, or transmits EPHI. A dedicated instance is one that runs on a physical host that is not shared with any other AWS customer. Finally, customers must record and retain activity related to the use and access to EPHI. So logging, retention of logs, document retention policies are absolutely critical and definitely the responsibility of the customer. The BAA with AWS does restrict the number of services that can be used to store or process PHI. These include EC2, EBS, ELB, S3, Glacier, Redshift, and most recently, DynamoDB, RDS for both MySQL and Oracle, as well as EMR. And these recent additions to the list of compliant services on the BAA are very exciting and have really opened up a dramatic expansion of capability and capacity for big data analytics. So with that being said, let me talk a little bit about some trends that we're seeing in the marketplace. There are three major factors that are driving adoption of cloud technologies, AWS, particularly as it relates to big data analytics in the healthcare field. The first is a massive proliferation of data that can be collected. So the government mandated that the healthcare industry migrate to electronic health records or EHRs. So all the manila folders that used to sit behind the receptionist's desk at your doctor's office are now in computers. That's a dramatic amount of data. I can't overstate how much data EHRs generate. On top of that, we have a huge proliferation of wearable devices, of implantable devices, of swallowable devices, and these are producing data at absolutely unthinkable rates. So that leads us to the second innovation that has been happening, which is regardless of whether you can produce enough data or how much data you produce, you have to store it somewhere. And the nominal price of storage and capacity of storage is unthinkable, even 2, 3, 5 years ago. Storage is essentially unlimited and essentially free. And so at the very same time in history that we have devices and computer systems producing unfathomable amounts of data, we suddenly have the ability to store this data almost unlimited at incredibly effective prices. Finally, if you can produce and store the data, unless you can do something with the data, it's essentially useless. So the third thing that we're seeing right now is that you can essentially instantaneously spin up a supercomputer in the cloud, process data in near real time, produce the types of actionable results that Fahad talked about, and just as quickly spin down that infrastructure so that you're only paying for what you use when you use. So producing a massive amount of data, being able to store it, being able to process it, being able to instantaneously produce actionable items, all at costs that were unimaginable just 5 years ago, are some significant changes that we're seeing in the industry that are really driving toward cloud adoption, particularly on AWS in the healthcare field for healthcare analytics applications. With that, I'll turn it over to Chris Crosby to talk some specifics about how to use AWS for a healthcare reporting architecture.
Hey, thanks a lot, Jerry. So yeah, we have spent some time talking about the trends and the care merge application, and then some of the great benefits that that application can provide. But as we wrap up here, I just wanted to conclude today's webinar by giving some details on what your maybe the very first reporting architecture, such as the one we discussed today, would actually look like on the AWS cloud. So this is a collection of AWS decoupled services that typically would be used when putting together a reporting architecture. Now I'm going to briefly describe each of these as I walk through how they actually connect. So we're going to begin our architecture at the Elastic Load Balancer. This is an Amazon load balancer service that's going to auto-scale to meet the demand of our web traffic and allow us to distribute those incoming requests to our web servers that could actually be spread across physical locations, which we call on AWS availability zones. So the ELB, that can terminate SSL, but we also want to be sure to use SSL behind the load balancer as well. So the web traffic, it comes into what we call an auto-scaling group. Now, an auto-scaling group automatically adjusts the number of reporting servers depending on the application needs. So this group, they could be configured to scale based on a variety of metrics, things like CPU usage or incoming connections. And what the group actually contains are Amazon Elastic Compute instances, otherwise known as EC2, which run the actual reporting server software. So the reporting server software, that can be pointed at database services in the cloud, which alleviates much of the management overhead that you would normally encounter with running databases in a traditional data center. The two most common database services found in reporting architectures today, especially these basic ones, are Amazon Relational Database Service, or RDS, and Amazon Redshift. So RDS, it's a managed version of common database platforms such as Oracle and MySQL, and it's typically used for those data marts where you have highly interactive reports and ad hoc querying is done in the report where it's really hands-on. Redshift, on the other hand, it's a petabyte scale data warehouse that's offered as a fully managed service, and it lets you quickly slice, dice, run aggregations across these very large data sets. And both of these, they offer a lot of advanced security features that make it a lot easier to meet your HIPAA obligations. And on the next slide, we're going to dig into a little bit more of those features. But the final piece, before we do that, the final piece of this architecture is another EC2 instance that can be used for the management of your reporting architecture. So often reporting environments, if you think of something like Tableau, it's going to require a server to be up and running licensed software or other management tasks that your reporting applications need to check in with. Now, usually SSL is not going to be required for this, and it's unlikely that these scheduled check-ins are going to require a scale-in, scale-out capability. However, we probably do want to be alerted in the event something were to cause a disruption on this server. So we could use something like Amazon Simple Notification Service, also known as SNS, to alert our team if there is ever an issue with this server and to avoid any kind of reporting server downtime. So as promised, I'm now going to jump into some of the features of Amazon Database Services that make it easy to meet your HIPAA obligations. Now, the easiest way to get started with database encryption of your data marts is to make use of Amazon RDS, either the MySQL or the Oracle engine if you're using PHI. And to protect your sensitive PHI data, you really should consider the following best practices for Amazon RDS. You should have access to the database enabled only for the applications coming into the database, so from that reporting server tier. And you want to do that with either appropriate security groups, which are kind of layer 4 firewalls, or network ACL rules. Now, any data that has the potential to contain PHI should always be encrypted by enabling the encryption option for your Amazon RDS database instance, as you see in that screenshot in the bottom left. And then data that's encrypted at rest, that includes the underlying storage for a database instance, its automated backups, read replicas, and the snapshots. And then for encryption of data in transit, MySQL provides a mechanism to communicate with the database over a secure SSL channel. And then likewise, for the Oracle RDS, you can configure an Oracle native network encryption to encrypt the data as it moves to and from a database instance. And then for encryption of data at rest within Oracle, you could also take advantage of Oracle's transparent data encryption and by setting the appropriate parameter in the options group associated with the RDS instance. And so with this, you can enable both TDE, table space encryption, which encrypts the entire application table, and TDE column encryption, which encrypts the individual elements that might contain that sensitive data. So that way you can just protect your PHI and then not have the overhead of encrypting everything. And then for an additional discussion on the details here behind RDS encryption mechanisms, you might want to check out the AWS HIPAA white paper that can be found on our website. And that's got a lot of great information for both databases and other aspects of HIPAA compliance on AWS. But with that, the next managed database service I'm going to briefly talk about is Amazon Redshift, which is our fast, simple, cheap, petabyte-scale data warehousing solution that's really perfect for those batch reports that you want to slice, dice, and run aggregations across very large data sets. So Amazon Redshift, it provides database encryption for its clusters to help protect that data at rest. And when customers enable encryption for a cluster, well, Amazon Redshift encrypts all the data, including the backups, with a hardware-accelerated AES 256 symmetric key. And then Amazon Redshift actually uses a 4-tier key-based architecture for encryption. So these keys consist of a data encryption keys, a database key, a cluster key, and a master key. And the cluster key is what encrypts the actual database key for the cluster, and that's what you as the customer control. And you can choose to either use AWS KMS or AWS Cloud HSM to manage that cluster key. And then for in-transit encryption, Amazon Redshift supports SSL connections to encrypt the data, and server certificates actually will validate the server certificate that the client connects to. And so by default, cluster databases accept a connection, whether it uses SSL or not. So to configure your cluster to require an SSL connection, you probably want to set the require SSL parameter to true in the parameter group that's associated with the cluster. And now I'm about to hand back to Jerry for some next steps. But before I do that, I just wanted to say that all these mechanisms I'm describing today, they're consistent with the HHS guidance at the time of this webinar. But customers, you really should stay up to date with the latest HHS guidance to make the determination on if these best practices are actually going to meet your compliance needs. And so with that, I'd like to hand back to Jerry for some next steps.
Great. Thanks, Chris. Appreciate that. So here's some, before we move on to the Q&A section, and again, if for any late joiners, if you want to type in any questions directly into the GoToWebinar panel, we're going to go through those and answer those across the three of us. Here are some things that we've seen customers who are successful on AWS take as next steps. So one is try it out. We always recommend an actual pilot project on AWS, if not necessarily with identifiable PHI right from the start, but it's a great way to get familiar with the environment. Very, very low investment, no upfront investment, pay-as-you-go environment. So absolutely recommend start piloting projects on Amazon Web Services. If you decide that you might want to pursue a migration of an existing system to Amazon Web Services, look for financial factors. For example, equipment that's reaching end of life, where you might have to make a multi-million-dollar capital expenditure, colo leases that are reaching the end, backup appliances that are filling up and requiring the purchase of more space, SANs that are running out of disk space that require capital outlay. Each of these are great inflection points to begin looking whether you could head off a capital expenditure by migrating a particular workload or storage requirement to AWS. Thirdly, there are companies out there, clearly like CareMerge, who have been wildly successful in their migration to Amazon Web Services and in taking advantage of some of the capabilities that really impact their businesses in a very positive way. So there are a lot of case studies out there, a lot of companies like CareMerge that have experiences that are obviously, in the case of this webinar, willing to share those experiences. And finally, don't go it alone. Amazon has a healthcare competency designation. There are 7 global consulting companies that have their healthcare competency. Cloudticity is one. And companies like Cloudticity can definitely help maximize your security, the value, and chances of success on Amazon Web Services. So I'll ask Fahad and Chris to come off of mute. And here's our contact information that you could record. Feel free to reach out at any time. And with that, let me go through a few questions. One question is, can you answer how AWS compliance can be obtained for source data that contains PHI? We talked, so AWS compliance, there's no certification for it, but AWS is very prescriptive in their description of how PHI must be handled on AWS. We went through it in brief, but there is as Chris mentioned, HIPAA white paper. If you go to aws.amazon.com/compliance, there's a link to it. That's an outstanding reference. While you're on the compliance page, there are many other white papers that are incredibly valuable around security architectures and that sort of thing. But AWS does support PHI in the manner that we briefly touched on in this presentation, and that's much more fully fleshed out in the actual BAA document.
Yeah, and just to add on to a little bit of that, it is what we call the shared responsibility model, and that's the model that we use for all security, and the HIPAA compliance sits on top of that. And so there's certain things within the BAA that we're going to agree to do. We're going to take care of a lot of the physical data centers, basically the hypervisor on down, and then you're going to be responsible for the operating system on up, and then we're going to share that HIPAA responsibility in that way.
Great, thanks. Another question, does traffic inside a VPC between instances or services need to be encrypted? For example, for traffic from an EC2 instance and RDS in the same VPC, or traffic between two EC2 instances in a single VPC? The short answer is, if that traffic contains ePHI, yes, it must be encrypted. Question probably for Chris. Would you discuss implementation and compliance considerations for SQL Server shops?
Do you want me to do that right now on the phone? So there's right now, the way SQL Server works is it's going to be stored on an EC2 instance. So we do offer a version of Microsoft SQL Server for RDS. As of today, that is not yet eligible underneath our Business Associates Agreement. However, you could still install Microsoft SQL Server on an EC2 instance, and then all of the EC2 rules would just apply there. So you're going to turn on your SSL for connections into that SQL Server. You're going to put that EC2 instance into dedicated tenancy, and you're going to just make sure all the data is encrypted in, out, and at rest. So you could potentially use EBS volumes for that, or you could use your own at-rest encryption, or if it's all the data is within the SQL Server database itself, you could turn on the Microsoft SQL Server transparent data encryption. But the key there is take advantage of the SQL Server features and then put it on EC2 today.
And we have many customers that have done that. We have some customers that use transparent data encryption in conjunction with Cloud HSM, which is an appliance key management device that is supported at AWS, and others that use it with the native EBS encryption for encryption at rest. But SQL Server is a very strongly used platform in the healthcare community and works great on EC2 instances on AWS. Another question, the sample architecture that was shown made use of SNS, but an earlier slide showing the services available under the BA did not contain SNS. Can SNS be used in a HIPAA environment?
Great questions. Oh, you want me to take it?
Yeah, go ahead, Chris.
Sure. Okay, so just to be clear, when you're in a HIPAA environment, the rules that apply for the BAA are strictly for PHI. But in a HIPAA account, you can still use any service that you wish, as long as it's not containing PHI. So in the example I had with SNS, SNS was connected to the management server, and so SNS was used as a way to alert your staff that the server went down. So for something like that, you can completely do within a HIPAA account because you're not going to be sending PHI just as notifications. So if you had another application where you're sending out notifications about patients, that would be restricted, but in this example where it's just sending notifications about a server state, that's okay.
That's a great clarification. I see a few other questions around, do instances in a HIPAA environment that don't store or process PHI need to be dedicated? do communications between instances that do not store or process PHI need to be encrypted? The answer is no. The BA is very specific that all communications or all instances that store and process PHI must be dedicated. Those that do not store or process PHI do not need to be dedicated. In practice, I will say that our recommendation is generally to build a VPC with dedicated tenancy, because once you have one dedicated instance running, it doesn't cost very much more to add 2 or 3, or the hourly fees are only about 10% higher. And the cost of failure in this industry is pretty high, and so we generally recommend better be safe than sorry. That's a Cloudticity recommendation, maybe not necessarily an AWS recommendation. But if you have, for example, infrastructure servers, we have a lot of clients that use Jenkins, for example, to do continuous integration, or the license servers that Chris mentioned earlier for perhaps Tableau. Those can easily be segregated off into a non-dedicated VPC and do not require encryption nor dedicated instances, as long as you're absolutely certain they do not store or process PHI. Chris, do you have anything to add to that?
Nope, I thought that was good.
Great. Okay, so a couple other questions here. There's a question, if they're on dedicated hosts, how do you handle host failures to ensure data service is available?
I'm sorry, one more time on that question.
If they are on dedicated hosts, how do you handle host failures to ensure data service is available?
So just to be very clear, the dedicated host, what that actually, so there's a couple different terms here. There's dedicated host, which is a new service that we released where you actually buy the entire host. What we're talking about for HIPAA compliance is dedicated tenancy, which is slightly different. What that means is just the host that is allocated to you. That's only going to be for you, one particular customer. Now, in the event of a failure, you're going to do the exact same thing that you would do on any other type of EC2 instance. Nothing changes except we just track that you are on your own host. So nothing else is going to change. So the same troubleshooting that you would go through, so maybe trying to restart the instance and get it onto a new host, all that same stuff, it still applies. When you're in the console, the only thing that changes is there's a little flag that says, yes, this is dedicated tenancy or dedicated VPC. All of the features and the services work the same way.
Great, thank you. Another good question. How will data be protected in AWS? Encryption? If so, whose keys?
So this is one of those situations that we talked about earlier on the shared responsibility model, where it's really up to the customer for how they would like to store and manage their data. Now, AWS does offer a lot of options that make it very easy. So we make security easy by default, and we offer a lot of kind of easy buttons. But if you wanted to encrypt all of your data with your own on-prem HSM and just send the bits back up to AWS, that's your option. We don't want to limit customers, but at the same time, we do want to offer a lot of nice, easy features for you as well.
And I'll say that across the board, we have customers that take advantage of all sorts of different security or key management capabilities at AWS. Everywhere, everything from their own HSMs, and you can upload your own keys. For example, even when you do server-side encryption on S3, AWS has a great key management infrastructure service, and they also have the ability to natively encrypt EBS volumes, either with default keys or key managed keys, as well as a number of encryption options for S3. I'll reiterate across a number of our customers, particularly exclusively in the healthcare field, that there's a wide range of options that offer a very high degree of security. Finally, there's somebody is asking for a repeat of the URL for that white paper. It's aws.amazon.com/compliance, and on that page you'll find a link to the HIPAA white paper. So Final question here. Is there a best practice for multi-region redundancy for encrypted RDS instances, given that the KMS keys are region specific?
RDS does not actually go across regions. There's not a way to do it today. The way RDS works is it actually goes across availability. Your backup for your secondary database on RDS goes to a different availability zone, which is a separate physical location, and it's not region based. It's availability zone based.
Got it. Thanks for that clarification. There's a question. So we were speaking of dedicated hosts, not dedicated instances, correct? It's actually the reverse. The BAA requires that any EC2 instance that stores or processes PHI must be a dedicated instance. It can be a dedicated instance launched onto a dedicated host. Any instance launched onto a dedicated host by definition is a dedicated instance. But the BAA does not require dedicated hosts. It requires dedicated instances. So with that, I think that is the end of the questions. Again, I want to thank everybody for joining us either morning or afternoon, depending on where you are in the world. We will follow up with an email that contains both a link to the recording of this as well as the slide presentation. Thanks, everyone.